Over the gas tank then.
Okay, MIG welding. This is called GMAW, gas metal arc welding. The slang name is called MIG welding. If you go for an interview or something and you're talking to a future employer, you might want to talk about GMAW. Now if he says, oh, you know how to MIG weld, then you can change the conversation to I know how to MIG weld and get less formal. But GMAW is the correct.
What's the acronym stand for?
Gas metal arc welding. Okay, so we use gas. We use argon 25%, or 75% argon, 25% CO2, or pure CO2 for your shielding gas. The shielding gas, what it does is shields an atmosphere around the molten metal, so it's non-reactive with the oxygen and water vapor in the air. What you need to watch out is these tanks are under extreme pressure. They're under about 2,200 pounds and down per square inch. So if you go to move these things and travel across the shop, do it slowly, make sure something doesn't stop the wheels and create a lifting motion where this falls, okay? Move it slowly. If you're moving these in a truck or so, you need to remove the regulators and put a protective cap on. This cap needs to be screwed down on here securely. Never lift the bottle by the cap, because sometimes these threads might be loose and you'll knock this cap into your face or it won't feel so good. When you lift the tank to replace it, you're going to grab it like a bear and lift the thing up. Always make sure the machine has a chain or a strap which straps this down completely so it doesn't move and fall out of here when you move it. Before you start the machine or move it around, check the wheels that the clips are on and the washers haven't fallen off. Sometimes they'll hit a fixture in the shop, pop the clip, this wheel will fall over and the machine might tip, creating a hazard. So do a visual inspection before moving the machine or setting it up. One of the hazards is electric shock. Make sure you do not touch these prongs. These are high voltage prongs. Never come around and do this. Always hold it from the outside. Keep your fingers away from those copper elements there. Plug it into the receptacle. Make sure it's nice and tight. When you're welding, we have a work clamp and we have our heat here for the stinger. The work clamp needs to go to the bench or whatever the material is grounded on. The machine feeds the wire automatically. It's wire fed. It comes out when you pull the trigger and this creates the current. Never put yourself between the work clamp and the current. You don't want to be touching both of these at the same time. You get a horrendous shock. It probably won't kill you because it's direct current, but it'll give you a shock. So.
Oh, it's not AC then?
No, AC. The machine is AC, but it inverts it internally, so it comes out as DC. Put yourself between the current flow, which is between the work clamp and the electrode here. The wire in this case, when I pull the trigger, comes out automatically. That's a wire feed. When you stop pulling the trigger, it stops.
How long should it be?
It stops the current flow. Now, this to be ideal is we're going to set this about 3/8 to 1/4 of an inch from the end of the contact tip. So I'll take my little dikes here and we'll cut this off right at the end here. So we're going to take out about 1/4 to 3/8 of an inch. The contact tip is down inside here. This is your contact tip, should be tight. There's a diffuser inside, and this is your shield nozzle. This nozzle provides gas around the immediate area that's being welded. This contact tip needs to be tight at all times. Periodically, I'll take a wire brush and I'll clean off the surface here.
Does it get clogged?
It can get clogged if you don't keep it clean. There's little orifices, little holes here. When you pull the trigger, gas comes out of these holes.
Now there's a spatter like spray, isn't there?
Yeah, we use an anti-spatter to keep the buildup on here. Let me go see if I can find some. We leave off with anti-splatter. Anti-splatter, you'll spray the tip here. When you use anti-splatter, it's like putting Pam on your pan when you cook eggs or so. It keeps the berries from sticking to it. If you use anti-splatter, take a wire brush, hold the nozzle down, because if not, the debris falls down, clogs the orifices. So you go like so, pull out the excessive, kind of tap it.
And this would
falls
be
out.
after you sprayed it with
After you spray it
So
with
you do the
anti-spatter.
anti-spatter with the cone on or off?
I do it with it on. When I do put a new tip in or a new contact tip, I'll spray all this down, spray the insides of this, and then stick it out.
Okay.
Just to keep it from sticking. Down at El Cajon, we don't use anti-splatter at all. And the tips get clogged up a lot, and they sticks the contact tips. So I'm trying to get them to use more anti-splatter. Anyhow, I'll show you how to MIG weld here in a second.
What about settings? 'Cause that's where I always get.
When we work with the MIG welder, we're going to hold this up in a direction like so. We're going to hold this perpendicular in this direction, and we're going to kick it about 15 to 20 degrees in the direction we're going to move. You can push it or you can pull it, but it's recommended that you push the thing, which gives your shielding gas area to go, and it's just ahead of you as you're moving it. Make sure it's free of dirt, grime, grease, paint.
And you said
rust.
oxygen is what the gas is for?
Yes, oxygen, it keeps oxygen out of the weld, because when the weld is molten, you're going to make the metal molten, which is liquid. At that time, you're about 2,400 degrees Fahrenheit, and it's extremely reactive with the outer elements, especially oxygen. If you weld and you see little holes in it and it looks like Swiss cheese or a meteorite, something's not right with your shielding gas. You need to turn the pressure up, the tank's either out, or maybe you're pinching a line that goes into the machine.
Go ahead.
Settings. This machine here has a little index card inside, and it'll tell you what your weld thickness is, what your materials are. This one's not lifted here. But you can see your different sizes here, and they'll tell you how to have your settings. But as for 1/8 material, so we'll set this about the voltage about 19, and we'll set the wire speed about 21, 22. So this would be up here about like so. That's 1/8 mild steel. Thinner material, like if we were going 16 gauge, we'd turn this down to about a 16, and we'd run this wire speed approximately 16.5 if we're doing 16 gauge sheet metal.
So the left dial is for the is the voltage
And this is wire speed.
and the wire speed.
And here's your symbol for wire speed. It's like two circles with a line going through it, which is pushing the wire out. The V is for the voltage. So we're going to go up about 18.5, 19, and then I'm going to go about 21, 22 with the wire speed.
Yeah.
Put the thing together if you have any doubt about putting the contact tips on or where the parts go. It also has a guide and telling you the approximate wire speed and voltage that you need for various thicknesses.
Yeah, go ahead.
Okay, so your positive
That was on
lead,
video.
the lead that has your stinger on it, is going to always be on the positive side. You don't want to switch these out. The only time you would switch this is if you're running inner shield. Then we would make the lead negative, which would be straight polarity. Right. This is an older machine. This one here, to change your heat ranges, you'll unplug one and plug it into the other. Your heat range 4 is in the middle heat range. This is probably up to a good 1/4 of an inch here. Anything higher than a 1/4 of an inch, we'll go up to 5. For heavy duty stuff, we'll go to 6, which is high. Right now it's right in the middle of.
And the other one we did it with the dial and the digital.
Yes, we did it digitally. And over here on this machine, we have a dial that does the same exact same thing. We have voltage and we have wire speed. Voltage is up here, your wire speed is down here. When in doubt, look at your V, or you see the symbol for wire speed. This has both, it's even written out.
So this is like the first generation on this one over here.
Yeah, this is an older MIG welder, does virtually the same thing as the dial one. This is dial, the other one was a digital.
Okay, so what are these 3 other dials for? Is it wire speed?
This has a burn back, and this is for spot welding. This is a spot welding accessory. We didn't use it very much, but this is mainly for general welding in here. And this is your wire speed.
So we're going to leave the switch on continuous welding, not on spot welding.
Yeah, we're
At the
leaving
top
on
up there.
Yeah, continuous welding here. This is spot welding here. This has a timer, tells you how long you can run it. This is good for like putting auto parts together or putting new panels on if you're doing auto.
So it's a good feature then to have.
That's a good feature if you're doing auto panels and putting them back together.
Okay. So it's almost like a timer then.
Exactly.
Because it has a welding timer.
Right,
So you
exactly.
just set the amount of time it burns.
The burn time and all that, and how long is you'll do a test piece, and then away you go.
Okay.
But it
So
makes
good for sheet metal.
yeah, makes good little spot welds.
Okay. Personal protective equipment.
Yes.
PPE.
PPE. I want to go over PPE, which is most important. As a welder, you have ultraviolet and infrared light. You want to keep shielding that off your body. It'll burn your skin, it'll sunburn you, it'll burn your eyeballs. So what we're going to do is I wear these protective garments here. Some of them have leather sleeves, or sleeves you can wear if you don't want to wear a jacket. Like summertime, it gets a little hot, so you can put these sleeves on, just wear your sleeves. But you're going to get spatter on the front part of your torso. So I use these when I do spots and stuff that's not really heavy welding. When you're doing overhead and stuff, you'll take your collar, you'll turn your collar up, and then you'll fasten it in here so berries don't go down your back of your neck when you're welding overhead. Okay. I use these helmets here. These are photo-sensitive helmets. You set your setting. You have a delays inside. You can make the sensitivities greater. You can make it less by adjusting it here. Lighter makes it light. Darker makes it darker. Usually you run an average about 10. A number 10 shields out all your infrared and ultraviolet. If you're doing TIG welding, which is a little brighter, you might go to an 11 or a 12 on your setting. If you're doing
How
light,
do you adjust it then?
I just push my button right here, and let's see, it says it's at 9 right now. I want it to go darker. Now we're at 10.
Okay.
And if I want to go lighter, now we're at 9.
So MIG welding, you want to do what?
About 10, okay.
And TIG?
TIG, I'd probably go 11
And
or
stick?
12. Stick, I'd be back at 10.
Got it.
Stick rod, okay. So you have your sensitivities set up. Now, this is a photosensitive helmet. There are other helmets that have a fixed lens in it. This one has a gold lens. This one, you have to look where you're going, look through your lens here, and then put it down and weld. You should always wear a approved pair of safety glasses, even when you're welding. You need to have those on because pieces of the metal will expand and pop off. They're extremely hot. You're around 2,400 degrees. A piece of little metal or slag coming off of that, landing on your eye, could blind you.
So, for clarification, we want safety glasses.
You're going to wear safety glasses and wear your welding helmet.
No exceptions.
No exceptions. No exceptions. When you weld, you're going to use these gauntlet gloves. You put these on. They go over your sleeves, so welding debris does not go down your sleeve. When you're welding, everything shields off of you and falls down. Do not grab hot metal with your gloves because it dries out the oils and they become rigor mortis like, and you can't get your fingers in, and the manipulation and dexterity goes away. So these are here for shielding radiation and hot metal from you, not for grabbing and holding hot metal. Okay, so your protective equipment includes wearing an approved pair of shoes. You should have some kind of long pants with no frays or holes in it because the sparks will ignite those frays. It doesn't take very much.
So those wearing shorts are not allowed to weld?
Shorts, no, you're going to get sunburn bad. If not, you're going to get hot metal that's going to burn you. So shoes are the same way. Some guys wear these tennis shoes that have fiber on it or nylon, and it burns through the nylon catches to the little berries, the berries go down and they continue to burn. So you need to have like a good pair of leather shoes. You need to think about what you're doing prior to doing it. If you keep your focus, you're not going to get shocked, you're not going to get burnt, you won't put yourself in the middle of a current. So keep your focus with whatever you do. Whenever you open the valve on a carbon dioxide or MIG mix, which is 75% argon, 25% CO2, you open the valve all the way up and just cinch it. You don't need to wrench it all the way tight. Just open it and cinch it. It has a double seating valve. These are under extreme pressure. The double seating valve keeps the contents inside and keeps it from leaking out. If you have it in between somewhere, it will leak out through your handle here up through the stem of the valve. So if you open it all the way, it alleviates from it leaking out. It'll last quite a while this way. So do not leave this partially in between full and closed. To adjust your regulator, we turn the machine on. We have this is called a flow meter. The dial tells you how much pressure is inside the tank internally. This flow meter tells you in bars how much you're using per cubic foot per hour. And we're going to set this at 20 to 25 cubic feet per hour. And the way I adjust this is by turning this little dial here. So when I pull it like that, you can see the ball raised inside. And so I'm going to set that at about 30.
And you have the trigger on right now.
Yeah. So the wire comes out, and then I can manipulate and adjust that.
Can you adjust it into what?
Let's see where we're going to go. Let's see, it's 20, go 25. Right
And the
there.
same for CO2?
Yes, this CO2 and argon will be the same. We're going to weld up some 3/16 material. So that means this material is 3/16 in thickness. So we're going to run this thing about 19 and 21 on our wire speed. So the voltage will be 19, the wire speed will be 21. We have our gas tank on, all the way open with the valve.
That's
Set
25.
to 25 cubic feet per hour. And you adjust that right here by raising it or lowering. What we're going to do now is we're going to come in at perpendicular, tilt our torch head at 15 degrees, and then we're going to move in a lateral motion, trying to maintain an arc bead. We'll run stringer beads to just practice, and you'll get good at using and manipulating the head here. It's good to do that. Right now I'm going to show you how to put two pieces of metal together. What I'm going to do is tack it, and then I'm going to tack the other side so it controls the distortion. If you just tack one side, what it'll do is it'll start pulling apart. So it's important to tack one side and then quickly do the other side. So,
All right, hang on.
right now we're going to ask you to cover.
Okay.
Cover your eyes, and then I'm going to tack this. Okay, cover. Now I'm going to come over here and do the same thing. That's a tack weld. One of the things you need to do so you don't look. Okay, as I weld, before I strike an arc, I'm going to always yell out cover. When you hear cover, that means cover your eyes so they don't see the bright light. Okay, cover. I'm coming in 15 degrees and then I'm going to roll. Okay. As I hold it here,
15 degrees, right?
yes, I'm manipulating one side and the other. I can do that in little circles or little E's, or just the shake of your hand can do that. I make a effort to weave it from one side to the other, but not very wide. I want to maintain a bead about 3/8 of an inch in width, no more than that.
And what's your pull rate? Would you say to go forward or
My
back?
forward, I watch the size of the puddle here with as it turns orange, and I try to keep it a certain width. And if you notice, it's about 3/8 of an inch in width. So I'm going to do that again.
Okay.
Okay, cover. Not the straightest, but you get the idea.
So you
Straighter like that. So this is straight, like perpendicular. And then we'll just go 15 degrees.
15 degrees.
Okay. Now, if you're going to weld a corner of something, like say we're going to weld a thing like this, we'll come in at 45.
Okay.
So we're going to split the difference. So,
so if you were trying to do a corner of something, would you do it on the inside, right?
both sides.
Both sides.
And if I'm going to do that, if this is our piece coming in, I'm going to tack it here and tack it here real quick. Okay, and usually I'll put it on one side and I'll put it on the other side. If I don't do that, if I weld one side, it'll go it'll bend over to as it cools. Okay, so it's like the coefficient of expansion. The molecules are open here, and as they cool and contract, it'll literally pull that thing out of square. So you can put it in a jig, a vise, a clamp. Magnets that are square at 90 degrees, but the magnet has a tendency to pull the weld one direction or the other. So if I'm going to weld this something like that, I'll put a magnet in the middle, tack it here, tack it there, or I'll stick it on square, tack it, put a square on it, and either manipulate it back to square, and then I'll weld it again.
Then you do an actual bead on it.
Right. So when we weld, you come in at 90 degrees with your head, and then kick it about 15 to 20 in the direction you're going to move. If
And
I'm
doing
going,
C's or E's or
yeah, or little circles,
okay.
well, a lot of little U's. Depends on your
And you use two hands or one hand?
one hand, and use the other hand for guidance. Like
Okay.
So.
So you use two hands. One that's steady and one that hold.
Yes.
Yeah.
The 90 is like here, and then you're going to take it
Right.
like that.
And I'm squeezing it that way.
Yeah, and just put it right next to that weld there.
Okay. Oh,
Yep.
I didn't yell cover though.
Yeah, it's okay. We're
Cover.
done. Cover.
Oh no.
Hold it right there. Now just pull the trigger. There you go. You just got to get some practice. That's all.
Right.
Or lace weld. New teacher weld.
It's not bad. Started a little bit. There you go. And get a little closer once you start off.
Cover.
Okay. Now I'm going to hold this down.
So the tip was the cone. We call it the cone, right?
This is the nozzle here, which is the cone, and then you have your contact tip down inside.
And that was getting all clogged up.
Mhm.
So you need all that cleaned out.
Yes.
Okay.
And if you notice, I did this, and then I knock it down, and out she comes.
What about the metal's rusty? You get to clean
The metal's
rust off?
rusty, get rid of the rust. Actually, on this here, we should have ground the mill scale off, because this has mill scale on it right now.
Which is a protective coating.
Yeah, which is a process that it's on the surface after running it through the mill. It's probably a heat process. Actually it's a carbon slag on the outside of the metal. So to do a decent weld, we should have ground off the mill scale in the appropriate area.